between DME and Moldflow software, we really feel that we can now push the limits of what we can accomplish as far as thermal control. DME has been in the industry for over 75 years, working with the plastic injection industry, making mold bases and mold components as a supplier. And most companies are out for trying to reduce their cycle times, reducing the cost for manufacturing these components, all at the same time trying to produce a better product than their competitor. The strategy that DME has applied to this concept is adding TrueCool to our line of products, which is thermal control of plastic injection molds. And we do that through additively manufacturing conformal cooling cores and cavity inserts, lifters, slides, whatever the case may be. We'll run analysis on the mold as it exists today to find out those areas that are driving up your cycle time or increasing warpage, part stress, stuff like that. And we'll use the Moldflow software to run these analyses to find these areas. We'll then design a conformal cooling insert that'll go in place of those areas that are driving up the cycle time, run a comparative analysis, and then we will provide a solution through these conformal cooling inserts to the customer, who will then place them in their mold, which gives them much greater thermal control, increasing their output of their tool, reducing part stress, and all at a lower overall cost. So as an example, this was a cup and lid set for to-go containers for soup. The problem with this was they wanted to go from 125 million shots per year up to 175 million per year. So the first thing anybody wants to do when they want to increase their capacity is shorten the cycle if they can. The problem with this is the bottom of the bowl was warping severely, so they couldn't shorten their cycle. They were pretty much already at their minimum capacity. So what we did was we ran analysis on their existing water configuration. We implemented conformal cooling channels inside this dome here, and then what we were able to do was reduce their cycle by almost 25% by reducing their cooling portion. The cost to convert two tools over to conformal cooling was less than half the price than it would have been to add one new tool to their capacity. Not to mention the extra floor space they would have required, the man hours and things like that. Another brief example we could talk about is relating to warpage. For instance, we've got here a syringe barrel that was warping in the center, causing fatigue when the people were using the plunger. They had to increase the cycle time because of this warpage. One of the benefits of conformal cooling and additive manufacturing is if they were to enlarge the bubbler style cooling they had going through here, there would still be no support inside that channel, and therefore you're jeopardizing your structural integrity of your part and could possibly collapse over time. An additive manufactured insert is all one piece of metal, so as a helix style baffles inside there, not only does it divert the water in a helix style, it's also one piece, so it adds structural integrity. We were able to put a larger volume of water through there, move it at a faster rate, reducing the heat effect, ultimately reducing the cycle time, not only back down to their original cycle while producing a warpage-free part, we were able to reduce it 30% beyond that while still producing a warpage-free part. Before we were using Moldflow, when we first launched TrueCool, we did all of our analysis outsourced. When you use an outside source, you're not really getting to look at what the results are telling you. Now we can. It definitely saves us some money in the short run and the long run. So adding Moldflow to our capabilities has really helped us stay on that forward trend of always pushing the limits, always advancing the industry, and being the leader in the industry for plastic injection molding.